Let's first go over the properties of exponential functions and how to graph them. If we start with an exponential function, f of x equals, let's say 4 to the x power. Think about what is different than this function than what we have seen previously in the polynomial functions. In an exponential function, in a polynomial function, we had the variable and the base, and then the power was a whole number. Here, in an exponential function, the base is a number. It can be a whole number, but it can also be a rational number or even an irrational number, as long as it's not 0 or 1. So an exponential function has a base that is a number, a real number other than 0 and 1. Or negative 1, sorry. And then it has its variable in the power. The variable is what changes, so we can plug values in for x to get what this is. So if I were to take x to the 0 power, that would be 1. 4 to the 0 is 1. If I took x is equal to 1, it'd be 4 to the first power, which is 4. If I were to plug 1/2 in for x, 4 to the 1/2 power, that means the square root of 4, which would be 2. So exponential functions then have these very specific properties. First, exponential functions always go through the point 0, 1. And think about that for a second. 4 to the 0 power was 1. Anything to the 0 power is 1. The second property of exponential functions is that they always go through the point 1, whatever the base is. So in our example here, this problem will go through 1, 4. If my base was 10, the point would go through 1, 10. If my base was 1/2 to the x power, so we have 1/2, the exponential function would go through the point 1, 1/2. The third property of an exponential function is that it has a horizontal asymptote at y equals 0. So let's consider why that is true. If I take my base and take it to any power, so 4 to the 10th, that would be a very big positive number. But what if I go 4 and plug in a negative number, 4 to the negative 2nd? A negative does not make the exponential function negative. It makes the exponential function a fraction. So if I plugged in negative 2, it'd be 1/16, not negative 16. So keeping that in mind, I'm going to keep making my fraction smaller and smaller. It's going to approach y equals 0, but never cross the y or the x-axis. The last property, number 4, of exponential functions is the domain of all exponential functions is all real numbers. Think about, there's no restriction that I can plug into x. I can plug any number I want in. So the domain would be all real numbers, and the range is 0 to infinity because you have a horizontal asymptote at y equals 0, and you're always going to be greater than that. Let's take a look at how we would graph them. Alright, so when we graph exponential functions, use the properties that we just talked about. So we know that f of x equals 4 to the x power is going to go through the points 0, 1, and the points 1, whatever the base is. In this case, we have 4 to the x, so our base is 4. And then there's one more property that we can use. Let's say we have y equals 0 is going to be our asymptote. So let's plot our points. We have the point 0, 1. Let's see if I can get there. And the point 1, 4. There we go. That's good enough. Okay. And then we have our horizontal asymptote there. Alright, so exponential function, if we connect those 2 points, we know we're going to keep going up, and this is going to approach the asymptote. All exponential functions will have this exponential shape to it. Let's look at one more problem here. So if I have f of x equals 1/2 to the x power, that is going to go through the point 0, 1. It's going to go through the point 1, comma, whatever its base is. In this case, its base is 1/2. And then it still will have its horizontal asymptote at y equals 0. So we have the point 0, 1, and then we have the point 1, 1/2. Sorry, those are not very good points. Okay. And then we do have our horizontal asymptote at still y equals 0. And we connect those points. They're going to go up from there. And we approach our horizontal asymptote. Alright, so the exponential function, once again, it has that same exponential graph. This one is flipped though, so it's going the other direction, and the reason it's doing that is because we do have a fraction 1/2 that is smaller than 1. Now these exponential functions will always follow this pattern. However, you can do the same transformations to them that we saw earlier. So if you had something like f of x equals 2 to the x power plus 1. That plus 1 is on the outside, so we would move the exponential function f of x equals 2 to the x up 1. Or if I had f of x equals 2 to the x minus 5, that 5 is on the x power, see? So we would move this graph to the right 5. So they do follow the same transformations that we saw before.